Welcome to the Walton Pi. This is the second entry in my collection of videos on the binomial theorem. In this video, we are going to explain what the binomial theorem is, as well as give a few examples of how to use it. If you are confused about any of the topics covered in this, please see the previous entry where we go over the different aspects of what a binomial coefficient is, and that might be a little helpful. In our next video, we will then talk about the proof of the binomial theorem. The binomial theorem says that x plus y raised to the n can be written as the sum from k equals 0 to n of n choose k times x to the n minus k times y to the k. We can use this in quite a few situations, especially if we ever see a n choose k inside a summation. So, if we were looking at this particular example, where we are looking at the sum from k equals 0 to n of n choose k times 2 to the n minus k times 4 to the k, we can use the binomial theorem to say that this is equal to 2 plus 4 raised to the n, or 6 to the n. Another example might be this one, where we have the sum from k equals 0 to n of n choose k times negative 1 to the k. Now, this doesn't quite match up with the binomial theorem. Remember, we needed an x to the n minus k and a y to the k. So we have the y piece, but not the x piece. So the trick with this one is to recognize that we can always multiply by 1. And 1 to any exponent is still going to be 1, so we can multiply this entire sum, specifically the inside part, by a 1 to the n minus k. Which then allows us to be able to write this out. It's going to be the same thing as 1 minus 1 raised to the n, which is just 0 to the n, or 0. Now, very similar to that is if we ever have the sum of n choose k. Here we don't have any of the x to the n minus k's, we don't have any y to the k's, but just like the last time, we can multiply by a 1. Specifically, we will multiply by 1 to the n minus k and by a 1 to the k, because that is still just multiplying by 1. When we do that, it becomes clear that this is going to be equal to 1 plus 1 to the n, or 2 to the n. Thanks for watching. If you enjoyed this video and thought it was helpful, please consider watching part 3, where we go over the proof of the binomial theorem. In addition, please like and subscribe. It helps me out quite a bit.